Well, welcome back. So we looked at Simpson's rule and trapezoidal rule. So both of them and the Riemann sums can be used to approximate areas as long as we follow the correct formula. But sometimes formulas aren't always the easiest thing to grasp or the easiest to remember. So sometimes you can just apply the concept to a problem, especially if there isn't a particular function to calculate with. So sometimes you might not know what this is, like you might just have a graph. So let's see how we do that. So example 4, the rate of fuel consumption in gallons per minute recorded during an airplane flight is given by a twice differentiable and strictly increasing function r of time t. The graph of r in the table of selected values of r of t for the time interval 0 to 90 are shown below. Approximate the value of the definite interval with the subintervals indicated by the data in the table using a trapezoidal Riemann sum. So they want us to approximate this, and so here's the curve, and then here's the data in the table. So instead of like trying to remember what the formula is, we're just going to go off of the area of a trapezoid. So 1/2 times the height times base 1 plus base 2. So I'm going to do several of these trapezoids. So whether it's the first trapezoid, the second one, the third, the fourth, all of them have this 1/2 in there. So I'm going to factor the 1/2 out. So then I just have to worry about the heights times the sum of the bases. So I'm supposed to use the data in the table, and that'll tell me like what the intervals are. So the intervals, your first one is going from 0 to 30. So the h, when you are using the formula, the h is the horizontal distance. So it's the x's, or in our case, the t's. So if you're going from 0 to 30, that means your first h is 30. On your second interval from 30 to 40, h is 10. From 40 to 50, that h is 10. From 50 to 70, that'll be 20. And then 70 to 90, that'll be 20 again. Okay, so I have my 1/2 already factored out, and then I just have to follow the height times the sum of the bases for each of those trapezoids. So the first one, my h is 30, and then I have to do the sum of the bases. Well, the bases, those are the vertical sides, are the ones going up and down, or the y values. So that would be these guys here. So 20 plus 30, and then plus my second trapezoid, the 10, times the bases with it. So that would be the 30 again and the 40. Plus my third one, so the h is 10. The bases with it are 40 and 55. Fourth trapezoid would be the 20 for its height, and the bases 55 and 65. And then the last one is the 20 again, and the bases going with it are 65 and 70. So you've got this massive arithmetic thing that we have to work out. So we'll just do it really fast, and it comes out as 4,125. Now there are units in the problem. The units given of this were gallons per minute, so that's what you're integrating. So gallons per minute, that's a rate or velocity. So when you integrate velocity, you get like the position or like a distance or a total. So it's 4,125 gallons. So basically when you go from a velocity to, and you integrate it, the time unit comes off. All right, example 5. Let's go ahead and do this in another video since this one's getting a little long.